Dobar dan. Anybody that doesn't speak Croatian here? 1, 2, 3, okay. Then I have to speak in English, right? Or German, or Slovenian, you can choose. Okay, I'll do it in English then. Since I only have 30 minutes, I'll be short, quick, and don't ask me any questions. You can ask me later, because in 30 minutes it's very hard to go through all the errors you users do, and of course all the errors you developers do, and everything else. So I'm coming from the company actually called Real Security. We are a developer of BC Vault hardware wallet, and the thing is that because we are developing the wallet, we see all the mistakes that the user make, and those mistakes are quite big, and they cost a lot of money. So the thing is that first of all the users that somehow try to do anything with your solutions have to use blockchain. The concept of the blockchain itself, of course, completely unclear to the user. They don't understand it. They never even try to understand it. They just want to do some gaming or money or whatever. And the thing is that how do you interact with the blockchain? Of course, with an old solution that's called a public and private key. So it's quite old design, which actually consists of a stupid string, and that's it. And users don't even know that, believe me. You can come and work in BC Vault support and you'll see. They don't understand it. They don't have a clue. So even showing them that picture makes effect with the user because they don't get it. Now they somehow try to get it. But this is what we are protecting. So that's all. This is all that we have to protect. It's very simple. It's old technology, actually. It's not something that was developed a couple of years ago. It's actually something that was developed like 40 years ago or even 50 years ago. So the thing is, who's the owner of the private key? Well, the owner of the private key is the user if he holds the private key, which doesn't happen with exchanges, of course. And the thing is that that's why they want to have a crypto wallet. Either software, hardware, paper, whatever. They just try to hold the key. Well, they think they hold the coins. They don't, right? They hold the key, they hold the address, and that's it. And well, the basic requirements for holding the holy grail of your whatever you're doing is the private key. And well, how do we store the private key? It's very simple. You take existing technology called hardware security module. Banks use that for 40 years, 50 years. Your country certificate agency uses HSM for 40 years already. It's a box that's meant to issue signed things, storing the secure certificate to do it without exposing it. So it's kind of a crypto wallet, right? And well, of course, it's nice to have ability to create the backup. Because if your HSM box dies, well, out of luck. So that's it. I think we cracked it. That's it. You just buy a HSM and, well, problem solved. No, sadly, it doesn't look like that. And the thing is that we have a couple of attack vectors that just get more and longer and more problematic for the user. With each year, with each WAP 2 and 3 and 4 and 5 and 6 and 1,000 million that we're gonna have, we're gonna add attack vectors. But the thing is, if you look at the attack vectors, we have a couple of quite famous, quite normal IT-related or hardware-related attack vectors as supply chain, and of course the software and the hardware, and well, the humble user too. And let's look at all these different attack vectors, how they pose a threat to the user. They will not even think about it, but they pose a threat. And for most of them, I can give you a real example, a real one that already happened. Because the hackers, well, it's quite good to steal some money, right? And you can steal some money with crypto. So the attack vector supply chain. The one that users usually think about, I'm not gonna buy my crypto wallet off eBay, right? So that's supply chain attack for them. Well, it's not. Supply chain goes for any vendor. As you might know, there was a time when a Xerox machine in, I think, Russian embassy was sending all the data to US in 60s. It's supply chain attack on a hardware layer. You cannot prevent somebody doing something inside the chip, right? So even if you are an open source heavy believer, well, good for you. I don't think you are using open source hardware, or even open source router, or even open source internet, or even open source each layer down to the layer 1. Well, you're not. So whatever happens there, you cannot prevent it, but it can happen. How do we solve that? Well, obviously buying a component directly from supplier. So, for example, what we do, where do we buy the FRAMs, the ferroelectric RAM chips? Directly by Fujitsu. So you buy directly for a Fujitsu distributor, and that's it. You don't buy it on AliExpress or whatsoever, but you can. PCB production, same thing. If you have a big PCB, it's very easy to put some additional stuff on it. Some additional stuff might be wireless chip, Bluetooth chip, Ethernet chip, whatever chip, it doesn't matter. You might actually notice it if you have your own guys developing that, but that attack vector was also exploited already in the past. Not particularly with crypto wallets, I think, but it was exploited. So that's to think about. And of course, the most dangerous one, facility for packaging and assembly. That's the stage where things can happen. Different things can happen. Because obviously, I don't know if you are familiar with, but you could buy a ledger device that already had a ticket with the seed words on it, with scratch foil. So it was really looking legit, like scratch off these fields, and you will get the 24 words, and then put that 24 words into the wallet, and well, that's your wallet, right? The user was clueless. He was like, oh, very nice, yeah. Scratch, like a lottery ticket. So scratched off the silver surface, entered the, well, seed words, and well, the hacker was just waiting that something happens with the wallets on those seed words, because he was giving the ticket in every single box that somehow came into the supply. Not, of course, on a regular supply, but from eBay, Amazon, whatever. Because users don't notice. If you go to Amazon and you buy stuff, it might be shipped from Amazon, but it might be not shipped from Amazon. It might be shipped from somebody else, some other merchant. Well, risk rating on a supply chain, not so high, I would say. So users directly might be compromised, but usually not, because somebody did an extra custom chip that has extra custom interface code or whatsoever. That's more like government spy agency stuff. But it might happen. So the next one, software. That's a big one. The problem with hardware crypto wallets is that, well, you have to usually work on a computer to do something, or your smartphone, doesn't matter, same stuff, software. So when you interact with blockchain, even if you have the most powerful wallet, you cannot get the data without the software. As you might know or not know, you cannot ask Bitcoin blockchain how much Bitcoin you have. It doesn't exist. That's not a call. You have to have a database that you query and ask how much Bitcoin does sit on this address, and then you get a reply. So that's software. You cannot do that on a device. The thing is that software will always have issues. Bugs are there, always. Any kind of software on this planet will have bugs, does have bugs, and will have bugs in the future. It's unavoidable. And the thing is that the software side always has to be the untrusted one. You never trust software. That's why hardware wallets exist in the first place, because you don't trust the software. Meaning, the critical information, the private keys, the wallet, even the wallet address. Some people might say, well, why don't you cache the wallet addresses in the software applications for the user? Well, because some hacker might be smart and say, oh, well, they are caching the address. Oh, I'm going to change it. I'm just going to change the address the user sees in the application. That's why you don't do that. No, 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 no. You get the address from the device, and then you show the address. And then the user has to have the possibility to ask the device, is this the real address? And then the device on the display has to show the address and confirm that's the same address. Because a lot can happen on the software side. Well, obviously, hardware, software, they have to, well, do their stuff, right? They have to communicate. They have to communicate. They better have to communicate over the encrypted channel. Because if they don't, I might do stuff in there. And of course, software code must be written with the security knowledge already behind in your mind. There are a lot of things that you can buy off-the-shelf, security scanner, source code scanner, stuff like that, that will give you the most basic stuff like code injection, buffer overflows, and most important thing, up-to-date third-party software. It happened to car industry. I can give you a billion examples from car industry where a central media device in huge car manufacturer is completely exploited because they used the open source library that was not updated. So you will not be the one to, well, blame, but you still have to take care to be always up to date with what is available from the libraries that you use, because that might be exploited. Encryption algorithm development, of course. If something is outdated, you have to upgrade. You have to go on. That's it. Man-in-the-middle attacks on the hardware. Oof, a lot of stuff can happen here. So actually, I can redirect the data flow from the software to attacker, from attacker to the hardware, and just sit in between and change stuff. This is why encryption is really important. And I think last but not least, tampering on software side will happen. It will happen. Somebody will play with it. So you have to always work or develop around the fact that software will be exploited. It's not the last one, that's the last one. And of course, it's the easiest attack vector. You can do stuff on computer. You can take over somebody's computer, you can sit there, watch, change code, procedures, kill tasks, do new tasks, whatever, keyboard sniffers, things like that, really easy. Risk rating, very high risk to high risk, I would say. That's the usual thing that happens to the user, because they will exploit his machine, then keyboard sniffer, then enter your password, thank you for the password, then stuff will follow. Hardware. Rogue firmware happened to Trezor. They are very open source friendly, which is hackers are really proud to be able to compile the code you download immediately. You take the open source code from the Trezor firmware, change 3 lines, and say, whenever user says send Bitcoin to an address, send this address, to my address. You compile the firmware. It's just the question of distribution channels. It will work immediately. You just change 3 lines of code. It's not easy, of course, or not possible to distribute this firmware over the official Trezor channels, of course. It's not that easy. But if you convince the user that he has to upgrade the firmware because of the blockchain upgrade, or as they say in India, please, my customer, can you update the firmware with the new latest firmware? You get me, right? This happens. We have seen that. It happened. Side channel attacks. That's a stupid one. Some researchers claim, oh, you're really vulnerable. Because I can read the timing information and electromagnetic levels of your power cable, stuff like that. Yeah, they can. They can actually read it, but from so far away. So it's there, but you don't really complicate around it. Because software-defined radio, yes, you can intercept the communication, but from this far away, so it's not a problem, if you ask me. Same thing, meaning the man-in-the-middle attack on the data. So software wallet will say send to wallet A. Then I change the data and say, no, send to wallet B. And this goes to the device, and the device will receive request to send to wallet B. Where on the monitor, you will still see send to wallet A. And the thing is, of course, for hardware attacks, somebody has to kick your butt. They have to come into your house, they have to break in, they have to steal your device, they have to, as I said, use the scanners, like, can you enter the password now? Again, please, I didn't read it correctly, so maybe with a pistol they will just get it from you. They don't have to do that. So hardware vector, C. Not a lot of attacks, if any, happened on the hardware layer. I'm not counting brute forcing as an attack, like somebody lost a wallet and then he used weak password and so on. But the thing is that, well, the vector user, buying device from eBay, infected desktop where I can intercept the passwords, man-in-the-middle attack on copy-paste buffer, please pay this on this Bitcoin address, copy. Then the copy-paste buffer changes the address because it recognized the official format of the Bitcoin address to some other address, and user just clicks paste, but doesn't notice that the two are different. Phishing, of course, again, can you please send us the 24 seed words because we have to change something? They still do that. The users still send the seed words. The data between software and hardware is not signed. So the hardware doesn't care if something changes. The software doesn't care if something changes. Mixing up wallet addresses. That's a good one. Users love to do that. Sending Ethereum over Polygon because it's cheaper on an Ethereum wallet. Well, thanks God, on BC Vault that's not a problem because we offer copy wallet functionality. You have the same address on different networks, but they do that a lot. If you have made that mistake and you are unable to replicate the private key on a different blockchain to get the same address, sorry, sir, your money is bye-bye. That's a good one. Using third-party web services. That's a Web3 problem. I'll have a slide on that. I love that one. Forgetting PIN and password. The users still think we can help them. Like, yeah, but just help me. Yeah, well, I can't. The purpose of the device is to not allow access without password and PIN. It's not an if sentence in programming language, like if password wrong, then reject. No, it's not. It's if password, use password for decrypt. Does the data make sense? No. Well, obviously it's wrong. But users still think it's like that. Like if password not good, just, let me through. No, it doesn't work like that. That happened before, just recently again. Mixing up amount and fee. Some users just do it by mistake, I think. I don't know. And the backup issues, of course. Oh yeah, you mean those 24 words? Those were important? Yeah, like you don't have them? No. Where's your wallet? Well, on a button of the C. Well, good luck. You can better search for some diver or something like that. They don't get it. They don't have the backups. Well, of course, A+++. It's always the user, mostly. This is where we come to the point, Jesus. I mean, in 2017, we said, like, what the hell is that? I had a device that big with a display that I cannot even read because I don't have my glasses. So I couldn't read this display, it's so small. And I said, well, we can do that better. Our company is in security for 20 years already, almost, at that point. We are doing all the stuff that crypto wallet actually does. Let's develop one. So we said, okay, let's sit down and see what are the current problems with current wallets that users don't like, and let's try to do things differently. So obviously, there are some things we can do better. So FRAM, again, real example, flash chip will corrupt the data in a couple of years if you don't power it up. It will corrupt the data. It happened with Tesla, it happened with Audi. They had to recall hundreds of thousands of cars because of corrupt flash chips. That's why we are using FRAM. It's ferroelectric RAM that's used in fighter jets. It has retention of 120 years without power. It's resistant to EMP blasts, I don't know what. It costs a little bit more, like a little bit more, but provides security for the user. So, of course, microcontroller, everything else you have to buy from reputable distributor or supplier. Everything assembled by us, final assembly by us, initial programming by us. We don't do anything in China. Nobody does anything anywhere else but us. And I really hate those security stickers. You know the security hologram stickers that some people put in devices? Actually, nobody knows what's the real sticker. So whatever device, whatever sticker you put on the device and it says security, the user is, oh, good, it's secure. Well, those stickers are there because users think they're important. It's complete nonsense. But sadly, users still think it has to be there. It's really important security. It's not. The software. What do we do about the software? First of all, our client application is signed by Apple Developer Certificate and Windows Microsoft Developer Certificate, meaning that when you run the application, you will not get the warning. This is an application of unknown developer, blah, blah, blah. Do you really want to run it? No. Hey, we are talking about money here. Some crypto hardware wallets still don't have that. I mean the biggest, the big ones with a lot of money, they still don't do it. It's stupid. Client and device have to communicate encrypted over SSL channel, of course. Well, that's trivial. You just do the stuff on both ends. Critical data, like I said, wallet addresses, always read from the device. You don't cache it. You don't store it. You can run Ledger software without Ledger, and it will show you wallet addresses. Are those really your wallet addresses? Or maybe somebody played with the data? It's up to you. Exposure of client passwords doesn't matter because it's good to type in a long password on a keyboard. Nobody wants to do that on a small device. But then again, you have additional thing on the device, and everything combined provides encryption, decryption key. So the user will never know which is not right. This is important. Software code written with all the security on the mind. One software branch for everything, so Mac OS, Linux, Windows, one software branch, no problems whatsoever. You have to detect man-in-the-middle attacks. So hardware will sign the request, software will receive the request, sign the data, send it back, and the hardware will check if this is the stuff that was actually asked for. Sorry, software, hardware, software, obviously. So that has to be checked. So did I really get back the signed request for transaction wallet A to wallet B? Is everything still correct? Yes, it is. Okay, good. Did something change? Warning? No. Compromise? No. Contact supplier. And of course, everything happens in one application. If you do Cardano staking in a third-party application that just sends the request to a hardware device, what are you signing? I don't know, blind sign feature. That's a stupid one. So what are you signing? I don't know, blind sign feature. No, everything has to happen in the application so the user can be sure that he's signing what he requested. No, I support this blockchain. Well, I don't actually. So you have to download this application and download the 5 gigabit data, and then you will do something and create wallet, and then this will be sent to the request of the hardware device, will be blindly signed, and you just click confirm. No, because this is the most easiest way to exploit the user. You just change the manual a little bit, and user will follow through. Oh, obviously. Hardware. Double bank firmware storage. So when you do the upgrade, if you do something like pull the power plug, nothing happens. You didn't upgrade the actual firmware bank. The second one was upgraded. So only when this happens successfully, we will switch the bootloader, or the boot vector, sorry. FRAM, as I said, retention of data, not comparable to flash. Flash is for sissies. Password and pins are not stored on the device. Unencrypted data is not stored on the device. You can take the chip, you can rub it off, you can read it with microscope, you can do amazing things, and you will get encrypted data. So good luck with that. Client always checks the data, as we said, with hardware. Yeah, well, PIN has its own secrets which don't devolve because of security reasons. And of course, everything is developed by us. And then we are by the user. Look at the list. That's the real problem. How do we help the user? So, best effort temporary preparation. As we said, the crappy holographic stickers, well, they are there. But obviously, anybody can buy a holographic sticker and put it up and claim it's the real one, or even replicate it. So, somehow, okay. Software has to be very clear, very easy, and issue a lot of warnings when you detect things as fee that is like 1,000 euros. So, are you really sure? 1,000 euro fee? Is this cool? Things like that. Warnings on device. If a hacker takes control of your PC, they cannot do anything without somebody pressing things on device, right? Each wallet has own name, different password, and different PIN. You can even do that. You can have a wallet that has a name. That's cool. So dad wallet, mom wallet, sister wallet. And they can share one device because each wallet will have additional password and PIN that only they will know. They can share a hardware device, no problem. Encrypted backups. We do backups on micro SD cards, or you print out the QR codes on a paper, like old school QR codes. Everything is still encrypted. You can give those cards to your friends, to your mom, to your whatever. You can even upload files to Google Cloud. Whatever, it's encrypted. You don't know the password and PIN, doesn't work. So you can be safe that you can share the backup to different locations, not to lose it. Man in the middle is detected. Support of all different addresses as Bitcoin, SegWit, Legacy, everything as one wallet. It's a Bitcoin wallet, come on. User doesn't care about SegWit and Legacy and private segregated witness stuff, whatever. It's a Bitcoin wallet. We will take care of it. Just here are the address formats. You can use any. It's one wallet for your user. Use. Of course, you check the address, and I love that one. You know what equit means? It's a special boot mode that allows you to export raw private key. You have to pass like 1 million warnings. Don't do it. Equit means I know what I'm doing. So, at the very least, everything goes to hell. You can really export a raw private key of a certain wallet from BC Vault. Raw private key. The lowest format of the private key. Not seed words. We don't use seed words, by the way. That's stupid. Because we know what people do with seed words. Raw private key is the ultimate low level. If you have a raw private key, you can do whatever you want with this wallet. we do allow the export under specific conditions, which are quite tricky for the user to get to protect him. You can use passwords and pins that can be even empty. Yeah. You want to? I'll not stop you, because anyhow, you're gonna write it down and put it somewhere. If you want to, you can use empty password, empty pin. Somebody still has to steal your physical device to exploit that. Because obviously, if the device is sitting in your home, in your safe or whatsoever, well, nobody can access your funds. It's stupid to use empty password and PIN, right? But you can, or any combination of that. Of course, application notifications, updates, whatsoever, and of course, transaction data to native currency, the least you have to do for the user. So, but the number one thing is that. That's the problem. That's what hackers are after. After all these years, users still give that away. Yeah, well, they don't understand it. They don't understand that those words will actually give access to the wallet, which you will create in 3 months. Give me new wallet, give me new wallet. It's all linked in seed words. We don't use seed words because of that. Numerous different examples of give me seed words, whatever happened, those 24 words. This is the scratch paper I was talking about. So this was in a ledger, a new ledger device, with all the words written, and you had to scratch the silver fields like, oh, those are your seed words. Users did it. And of course, the latest and the greatest, Web3. The problem with Web3 is you have to communicate with hardware wallet with a web page. How do you do it? We used Wallet Connect. No, we don't use MyEther wallet because they suck. They are closed source, I call them, because they decide who they're gonna support. Well, with Wallet Connect, everything goes. You can do your own stuff. And what they did, at least they added that. So when you are talking with a web page, if that web page is not registered on their portal, it's gonna say unknown, at least that, or harmful. So they have a list of harmful. It's not their list. It's a list provided by a service that's provided by a provider that a lot of companies use. So they warn the user something's wrong. And of course, Ethereum, Polygon, whatever, EVM, smart contracts. Whenever you do stuff on Uniswap, it will ask you to sign the request to give access to 105 gazillion, billion, Google, lillion, whatever, maximum number of money in your wallet. You give them access to your wallet. Users don't get it, what they just signed. Show me how they can revoke that. Not on Uniswap. You have actual document. You have to go to Etherscan, go to developer beta tools, see the approvals, enter the address, check the approvals, click it, use the Wallet Connect, select the wallet, send the request to cancel, and then you will maybe cancel the signature. That allows them to access your money. Web3. Sadly, the more we add, the more the user is exposed to problems. And hopefully that will go to the better. We will always be there to implement whatever safety features there are available for us or the user. And well, that's it. Thank you very much. Hope you enjoyed it. Any questions, don't ask me as the developer there, or Mirjeta, the graphic developer. And thank you very much. Have a restful evening in Split.